Okay, good afternoon to one and all. In the previous lecture, we have completed the unit number second, that is DC motor. So up to today's lecture, we have discussed regarding both DC generator as well as DC motor. What is the construction principle as well as principle of DC generator also, construction as well as working principle of DC motor also, some of the different types of characteristics. So again we have discussed in case of DC motor there are some of the speed control technique is there. Also the starter it is used for DC motor. So these types of starter we have also discussed in the previous one up to this lecture. Okay, so today we will discuss about the next one unit is that unit number third, testing of a DC machine. So unit number third is that the testing of DC machine. So see, we know that each and every machine it can be tested. Once machine it can be manufactured, there are some of the tests it can be calculated, and manufacturer it will give a remark on that product. Any product we can call machine, or it may be any other product. So in that the remark it can be given tested, it is okay, right? No, बघितलं का कधी remark? एखादी मशीन कन्सिडर केली और यू हॅव परचेस्ड एनी बॅटरी, कुठलंही इक्विपमेंट बघा, एखादं इक्विपमेंट आपण परचेस करत असेल, एखादी 1 HP मोटर आपण परचेस करतोय, सिंगल फेज मोटर परचेस करतोय. सो ऑन दॅट देयर इज वन रिमार्क और वन टॅग इज देयर, दॅट इज एक टॅग दिलेला असतो, टेस्टेड अँड इट इज ओके, राईट? नो, असतो का? वेदर यू हॅव सीन द टॅग? Okay, see, each and every machine as well as each and every equipment, so there is a one tag is that it is the tested. And okay, so the testing it is very important to understand the behavior or to understand the some parameter of the machine चे जे काय parameter आहेत, how the machine it will be run, what are the condition, or what is the speed of that motor. So different types of parameter we will understand by judging the performance or by conducting one test. Okay, so see, once we have conducted one of the test, so if we have conducted one test, after testing we are able to understand the performance of the machine. That means suppose we have conducted one test, on that basis of that test we are able to tell the speed of that motor, as well as we are able to tell the torque of that motor. Also we are able to tell the efficiency of the motor. Okay, so see, testing it is important. Testing it can be important to judge the performance or to understand the performance of any machine. Okay, so that's why I am giving some introduction, that is testing of DC machine. In that testing it is very important. Now see, in case of testing of DC machine, there are different types of tests it can be carried out. So syllabus of this unit or unit content is nothing but direct and indirect method of testing. Second one is that the brake test. Third one is nothing but a Swinburne test, and fourth one is nothing but Hopkinson test. Okay, so these are the different types of testing which you understood. In that see, direct and indirect method of testing, then brake test, then Swinburne test and Hopkinson test. So these are the different types of testing we want to understood in this unit, that is testing of DC machine. Okay, see, so these are the unit content, that is direct and indirect method of testing, brake test, Swinburne test and Hopkinson test. So see, some of the questions it may be asked on this unit. So with the need sketch explain the Hopkinson test, as well as with need sketch explain the braking test or a brake test of the machine, also tell there some of the advantages and disadvantages. So explain the Swinburne test as well as with neat sketch explain the Swinburne test, what is Hopkinson test, how it can be carried out, some of the problem related to that. So these types of question it can be asked on that unit, that is unit number 3, testing of DC machine. Okay, see, we will see one by one. First one, the testing of DC machine. There are some of the important tests it can be carried out. That is direct test of the machine, indirect test of the machine, as well as brake test and Hopkinson test. See, the direct test method, it is also called as a brake over test. Again, the Swinburne test, it will be comes under indirect method of testing, and Hopkinson test, it is nothing but a regenerative test. Okay, so these 3 types of test it can be carried out, like direct method. So direct method, in that it is also called as brake over test. In a direct method of testing, we are directly putting load on the top machine. In case of indirect method of testing, we will see in the details, that is Swinburne test, it is how it will be comes under indirect method of testing, and Hopkinson test, it is nothing but it is the regenerative method of testing. Can anyone able to tell what is the meaning of direct and indirect? What is the meaning of direct and indirect? Suppose we are able to perform, or we are performing the test on DC shunt motor. So output of the DC shunt motor in which form? Output कोणत्या फॉर्म मध्ये असेल? Give me reply, all of you present, no? DC shunt motor output of the motor, it is in the form of electrical or mechanical? Hello? Roll number 32. Are you present?
Yes, sir.
Why you are not responding? I am asking question, no? Roll number 15. No. 19. 31. 31. 31 is not there. 34. 34 is there. Okay, we will discuss. Tell me output of DC machine, whether it is in the form of electrical or mechanical.
Mechanical.
Okay. See, this is a one motor. So motor, there is a input of the motor, it is in the form of electrical. So electrical input. Here, this one is the output of the machine, it is in the form of mechanical. So see, here it is mechanical output of the motor. So we are putting load directly on that of shaft of the machine. So it is nothing but direct method of testing. That means we are putting load, or we are testing this machine by putting a direct load on this output of the machine. Okay, so it is nothing but direct method of testing. We are directly kept some load on that machine, and we are taken some of the reading, and understood the behavior like efficiency as well as the speed torque characteristics, or it may be the torque produced by that of machine for particular load. So this some parameter we are understanding by performing this test. Like direct method of testing. What is indirect method of testing? Suppose indirect method of testing, here the Swinburne test, it is comes under indirect method of testing. So in case of indirect method of testing, suppose one of the machine is there, that is one motor is there. I want to test that motor, or I want to find out some of the parameter of that machine. Input to that of motor, it is nothing but it is in the form of electrical, and on the output of that machine I have coupled another one generator. Okay, so see the output of the machine, it is applied as an input to that of generator. Here it is motor, or this one is the generator, and here the power generated by generator, it is fed to that of load, or it may be here one of the one resistive load bank, it can be connected. Okay, here one resistive load bank, it can be connected. Now see, we want to test that machine, like I want to test this motor by putting some of the electrical load. Here it is some resistive load, inductive load, and capacitive load. See, if the load, it can be put on the machine, that is load, electrical load, it can be put on the generator output. So there is some changes in that of input to that of machine. Like this motor, it can be indirectly tested. Suppose see here, as we know that the A is equals to B. It is nothing but B is equals to C. We can call it as a indirectly A is equal to C, like that. That means we are not putting directly load on the top output of the motor. We are giving this output of the motor to the top generator. Generator generates some of the electricity, and this output of the generator, it is fed to the top some of the electrical load. That means we are indirectly testing the DC motor. Okay, so this is one type of indirect method of testing. And last one type testing is nothing but regenerative method of testing. So in case of regenerative method of testing, the Hopkinson test, it will becomes under the regenerative method of testing. Okay, now see, we will see one by one. That is first one, it is nothing but direct method of testing. Direct method of testing. Okay, now see, in this method of testing, the machine is put on the full load, and the whole power developed by that machine, it can be wasted by applying this brake. So we can call it as a brake over test. Now see how this test, it can be performed on the output of that machine. Suppose here it is one of the output shaft of that motor. On that shaft, one of the pulley, or we can call it as a one drum, it can be attached. Like one arrangement, it can be done. We can call it as a pony brake arrangement. Pony brake arrangement, like this. Here it is arrangement, it can be shown. So see, this is one of the pulley, or it may be drum. This one is the pulley, or it may be drum. This is directly attached to that of shaft of the motor. Motor shaft la kai kelle attach kelle. Now see, one of the pony brake arrangement, it can be done. So here some of the spring balance, it can be connected. So here this one is the spring balance. Suppose we can represent it is W1 or W2, or we can represent it is S1, S2. Okay, so here one of the one end of this pony brake arrangement, it can be fixed, and another one end, it is variable. Now see, this W1 and W2, it is here it is built, it can be connected by varying this wheel. By varying this wheel, we are applying some of the force on that pulley. या पुलीवरती आपण काय करतो, काहीतरी फोर्स अप्लाय करतो. So this force, it is in the form of kg, and this force, it can be shown by this spring balance. Okay, this spring balance, it will shows how much force it can be applied to that of pulley, or it may be output of the machine. Okay, so see, this part, it is rotating, and this belt, it is a stationary. There is a power dissipation, it will be occur. Whether power dissipation, it will be occur in which form? कोणत्या फॉर्म मध्ये पॉवर डिसिपेट होईल इथं? This wheel, it is an rotating part, this one is stationary part, and the output power, we are applying a brake or we are tightening this wheel so that there is a force it can be applied on that of wheel. So this force, it is applied to that of wheel, and this force value, it can be shown by this spring balance, or we are applying a weight W1 W2. So due to that weight, there is a friction, it can be present, or due to that friction, there is a power dissipation. It is in the form of heat. Itcha form मध्ये काय will power dissipate. Okay. See, the direct method of testing, it is used for a small machine because in case of large machine, it is difficult to dissipate a large amount of heat or large amount of power. Okay. So जी काही friction मुळे heat generate होणार आहे in between, the friction between this pulley and belt, there is a heat, it can be produced. Due to that heat is dissipation, it is used for a small motor, because in case of large machine, it is very difficult to dissipate this large amount of heat, or it is dissipate to the large amount of heat generated by this friction or belt and pulley arrangement. So it is called as brake over test also. Sometimes if the heat generated, it is more somewhat belt, it may be a damage like that. Okay, so it is not possible to use that test or to perform such test on a large size of motor or a big size of machine. Okay, now see, though this method, it is simple. So this method, it can be simple because we are just using one pony brake arrangement. Here the reading can be taken like spring balance reading, or weight, it can be taken W1 and W2, and we are just applying a brake by varying this wheel on that of pulley. So we are just applying some load, that is mechanical load, on that of output of the motor. So there is some friction between the wheel and the belt. Due to that frictional force, there is some power, it can be dissipated, it is in the form of heat. So this just, it is the simple method, but complication for the measurement of mechanical power, that is output power method. So see, can anyone tell me the formula for P out? What is the formula for P out? Calculation of output power. We have solved some problem related to that also. What is the formula? That is output power developed by the machine or motor. P out, it is equals to काय फॉर्म्युला आपण डिराइव केलेलं आहे? Anyone? P out, that is output power, it is equals to 2 pi nt divided by 60. Okay, what is N? N is nothing but speed of the motor. T is nothing but torque of the motor. Okay, so see, from this formula we are able to calculate or measurement the mechanical power output. So we are able to calculate mechanical power input in case of DC generator, and we are able to calculate the output power in case of DC motor. Okay, now by using this formula, that is 2 pi nt divided by 60, where N is nothing but speed of the motor, T is nothing but torque developed by the machine. This 2 pi is constant and 60 it is also constant. And the formula for calculating the torque, we have already conducted the practical, same practical on DC shunt motor as well as DC series motor, and we have calculated the torque. What is the formula for calculation of torque? Torque calculation साठी formula काय आहे? Spring balances, difference between spring balances, that is S1 minus S2 into radius of the drum, that is R, into 9.81. So this torque, it can be calculated in the form of Newton meter. Okay, so it is in the form of Newton meter. So the brake must be tight before the motor it can be started. Otherwise the armature may get damaged and the winding it may be burned. Okay, so in case of series motor, you people know that in case of series motor we have taken one precaution. DC series motor never be started on without load. Okay, somewhat load it can be put on the DC series motor. So near about 25% load it should be present on the DC series motor before starting the motor. Before starting the motor, we want to put some of the load like near about 25% load, as I have already tell while performing the practical. Near about 25% load should be present before starting the machine as well as before stopping the machine. Okay, start करण्याच्या अगोदर आपण 25% लोड काय करतो त्याच्यावरती पुट करतो in case of DC series motor. So otherwise the armature of the machine, that is DC series motor, it get damaged or the winding it should also burn. Winding पण काय होती, burn होते. So some calculation part, that is we have already done the calculation part in the practical, but also I am telling once again, that is while doing the calculation, first of all we are taking the reading of this W1 W2, or it may be S1 S2. We can call it as a spring balances, or we can call it as a weight applied on the top pulley of the DC motor. So W1 W2 or S1 S2. So if we have reading this, taken the reading, suppose the S1 is equals to 1 kg, S2 it is equals to 0.5 kg. We are taking difference between these two. It is nothing but S1 minus S2 or W1 minus W2. For calculating the torque, T is equals to, formula is nothing but S1 minus S2 into radius of the drum into 9.81. We are measuring this radius, and after measuring this radius we are using here for calculation of the torque and 9.81 to convert this kg into meter, kg meter into a Newton meter. So force conversion upon Newton मध्ये करतोय, that is torque, it is in the Newton meter. So torques come under Newton meter. After calculation of the torque, you people know the speed at a particular load, that is N, and after that we are able to calculate the output power by using the formula, that is 2 pi nt divided by 60. 2 pi nt divided by 60 चा formula use करून आपण काय करू शकतो, output power calculate. Once the output power it can be calculated, we know the supply voltage. We are taking the reading of supply voltage. Also we are taking the reading of current taken from the supply, that is IL. If we know this supply voltage and the current taken from the supply, it is nothing but V into I. So you people get the power input, that is Pin. Once power input and power output it can be known, then we are able to calculate the efficiency of the machine. That is efficiency is equals to output power divided by input power. So this is related to direct method of testing. That means by conducting a direct test, that is a breakover test, we are able to find out the efficiency of the motor. Okay, also we are able to find out the total losses of the machine, because you people know the input power, also we know the output power. So difference between input power and output power, it is nothing but total losses. With that it will comes constant losses plus variable losses. Okay, so this is one direct method of test. That means we are directly putting load on that machine. So if it is a DC motor, then we are applying some force on that of output of the motor. If in case of generator, so generator output it is in the form of electrical. So on that output of the generator we are putting load, it is in the form of electrical, whether it may be resistive load. Okay, so we are putting the resistive load, or it may be we are putting the resistive bank load. Okay, then we are able to find out the efficiency for particular load in case of DC generator as well as in case of DC motor. Okay, now see, the main drawback of this method is that the accuracy of determining the mechanical output power of the motor, it is limited. Okay, now see, Suppose this pulley, it is rotating in speed near about 1500 revolution per minute. Okay, this pulley, if it is rotating, because it is directly attached to that of shaft, so while it will be rotating, suppose it will be rotating at a constant speed and we are applying some load. If we are increasing load, at that situation this spring balances somewhat, there is a vibration, or it will shows that means it will shows the reading which is not correct because of the variation in the needle point, or it may be variation in the pointer. Okay, so that we are not able to take the accurate reading of the spring balance. If the accurate reading we are not able to take, then there is a difficulty to determine the mechanical output power. Okay, because if the accurate spring balance we are not getting, then we are not getting the accurate value of torque. If the accurate value of torque it cannot be calculated, then the power output, it should not be calculated accurately. Okay, so this mechanical power output calculation, it is a little bit difficult, because we are applying a brake to the top pulley, or we are applying brake to the top rotating drum. Okay, also alternatively, it is difficult to provide a full load. It is difficult to provide a full load for the large capacity of the motor. If the small motor is there, on that small motor we are able to apply the full load. Full load in the sense we are directly stop this rotor also. That means we are conducting a blocked rotor test. Rotor, it can be blocked. Okay, but if the motor or the machine, it is having a large size or the large capacity motor, it is not possible to provide the full load by varying or by this pony brake arrangement. So this is one of the drawback of the test, that is direct method of testing. Direct method of testing चा हा काय आहे drawback. Now see, this method of testing, it can be used for a small motor only. This is used for a testing of small motor. We are not using this test for a large machine or the large motor, because it is difficult to dissipate the heat generated due to that of frictional force. It is difficult to dissipate the heat generated by the pulley or by the friction between the pulley and the belt. So we are not able to dissipate that amount of heat. So this method, it cannot be used for a large type of machine. Okay, or it cannot be used for large motor. Large motor साठी आपण ही टेस्ट काय करत नाही, generally use करत नाही. We are generally using this test for a small motor, or it may be small machine. Getting? All of you getting now? So this is nothing but direct method of testing. Yes, give me reply immediately. Hello. Give me reply. Otherwise, I will put all are absent directly. I think no one is present here. Whether I call individual? Getting no?
Yes, sir.
Okay. So this is a direct method of testing. That means we are directly putting, suppose the DC motor is there, we are directly putting a mechanical load, or we are applying force to that of output of the machine. That means direct method of testing. Now see, second one test is that second one test, it is nothing but indirect method of testing. So in indirect method of testing, there is a Swinburne test, it will become. Indirect method of testing मध्ये Swinburne test it will come. We have already discussed regarding Swinburne test while performing the test or while performing the practical. We have already discussed. Now see, the Swinburne test, it is the simple method, that is simple indirect method of testing in case of DC machine. And in that machine, in that test, the motor, it will be run on the no load condition. And once the motor, it can be run on the no load condition, we are able to calculate the losses of the machine. That means losses can be determined, that is no load losses, it can be determined by performing this test. Okay, now can anyone tell me what are the no load losses? Which are the no load losses? कोणते कोणते असतात no load losses? No load losses, we have already discussed in case of DC series motor types of losses. There are different types of losses, that is constant loss, variable loss. So which are the variable, which are the constant, we have already discussed. So can anyone tell me the no load losses? कोणते असतात losses no load? We are able to calculate these types of losses on no load condition. Whether the constant losses, it will be comes under no load losses. Constant losses, whether it is come under no load losses. So there are constant losses we have discussed regarding eddy current loss, then iron loss, that is core losses, or it may be some mechanical type of losses like friction and windage losses. So different types of losses we have discussed. And the copper losses, it will becomes under the variable losses because it will depends upon the load current, that is I square R loss. That means it depends upon current, load current. So we can call it as a variable losses. In case of constant losses, there are core losses like iron and friction, as well as hysteresis or eddy current losses. It will becomes under no load losses or constant loss. So these losses, it can be calculated or it can be determined by performing the Swinburne test. See, here it is written, the iron and friction losses are determined by the measuring the input to the machine on no load condition. Okay, so we are able to calculate the iron loss and friction as well as windage losses like hysteresis and eddy current loss and friction and windage losses calculated by performing this test like Swinburne test on no load condition. So see, the Swinburne test, in that the machine, it can be run on only no load condition. मशीन जी आहे किंवा मोटर आपण ओनली नो लोड कंडिशनला काय करतो, रन करतो. So the machine or the motor, it can be run as a no load condition by giving a normal voltage and its rated speed. Also the copper losses are calculated from measured value of the various resistances. If you people know the value of resistance, suppose we are calculating the value of copper loss occur across armature, or we can call it as armature copper loss. So if we know the value of resistance, then we are able to calculate the value of copper loss, that is I square R, IA square RA. Now see, the Swinburne test, also it is called as a no load test. Swinburne test, it is also called as no load test. And this is the indirect method of testing for a large shunt machine also. Large shunt machine. See, this Swinburne test, it can be carried out whose flux remains constant. This test, it can be carried out on the machine whose flux remains constant. That means ज्या machine चे flux constant असतील, for that motor we are able to calculate the or we are able to perform the Swinburne test. So Swinburne test, it can be performed on the machine whose flux remains constant, that is phi is constant. So there are motor like a shunt motor and a compound motor whose flux are constant. On that two machine, that is shunt motor and the compound motor, we are performing this test. We are performing this test like Swinburne test. Okay. Okay, so see, in case of Swinburne test, in this Swinburne test, it is the indirect method of testing, and in case of Swinburne test, it is also called as no load test. We are performing this test whose flux remains constant. That is phi ज्या machine चे constant असतील त्या machine वरती आपण ही काय करतो test perform करतो. So see, in that the DC shunt motor and DC compound motor, it will becomes, because its flux phi remains constant. त्याचे flux जे आहे phi काय आहे constant आहे. Okay, so flux phi remains constant. On that machine we are applying the we are using this test, or we are performing this test, that is Swinburne test. Okay, now see, why it is called as indirect method of testing. That means we are not directly putting this machine, the load, it cannot be put on the machine directly, because we are running this motor on only no load condition. Only no load condition ला आपण machine काय करतोय, run करतोय. Once this machine, it can be running on no load condition, at that situation we are able to take the reading of no load voltage, VO, no load current, IO, and the power taken from at the no load condition, that is P input. Okay, so if this reading, it can be taken, and the speed of the no load condition remains constant, because it is the constant flux machine. So speed we are taken constant, or it may be rated speed. If once this reading, it can be taken, if this reading, it can be taken, and once this reading, it is taken, we are able to calculate the efficiency at a different load or efficiency at a predetermined load. Upon determine करणार efficiency by considering that much amount of load, it can be put on the machine. So that means by assuming the load, we are able to calculate the efficiency. So once this no load condition reading, it can be done, and once this reading, it can be taken, we are calculating the constant losses, and once the constant losses, it will be known, constant losses, it will be known, then we are able to calculate the efficiency of the machine at any desired load condition by assuming that much amount of load. Suppose consider the rated current of the motor, it is nothing but 10 ampere. Motor's rated current काय आहे 10 ampere. When the machine, it can be running on no load condition, ज्यावेळेस machine आपण no load condition ला run करतोय, at that situation, suppose motor, it will be take a 2 ampere current, voltage we are applying a constant voltage, suppose 230 volt, and power taken by the machine, it is nothing but suppose 50 watt. Speed of the machine, it is nothing but 1500 revolution per minute. Okay, now rated current of the motor, it is nothing but 10 ampere. We are assuming the particular load. Suppose 10 ampere चा मी 50% load assume केला, that means motor, it will be taking a 5 ampere current. I am just assuming. Okay, whether I am putting direct load on that machine, motor वरती direct load put करतोय का मी? Whether I am putting the load directly load on the top motor. मोटर वरती मी डायरेक्ट लोड पुट करतोय का? Give me reply immediately.
No, sir.
We are just assuming that much amount of load it should be present. म्हणजे suppose मी जर consider केला fraction of load I am assuming, suppose initially I am assuming 50% load it will be putted on the machine. Also I am assuming 75% load it should be present. At that condition 75% load काय आहे present आहे असं मी assume केलं. So 75% load as compared to that of rated load. Rated load च्या 75% load आहे म्हटल्यानंतर I am able to tell that is 7.5 ampere current it will be taken from the supply. At that point we are calculating the input power, we are calculating the output power, or we are calculating the input power and we are calculating the output power, because you people know the losses we have calculated by using a no load reading. And if the losses no, and if you calculate the input power, so because you people know the supply voltage, we have assumed the current, suppose current at this condition is nothing but 5 ampere. So according to this we are able to calculate the input power. Once input power it can be known and the losses it can be known, we are able to calculate the output power. And once output and input you people know, then we are calculating the efficiency of the machine. That is, we are able to calculate the efficiency of the machine. Okay, machine ची काय असेल efficiency आपण काय करू शकतो, calculate करू शकतो. Okay, so this is related to Swinburne test. That means we are not putting direct load on the machine. We are not putting the direct load on the machine. We are just assuming that particular load it should be present on that machine. Just assumption it can be done, and we are able to calculate the efficiency. That means suppose at 75% load motor it will be gives 80% efficiency. At 50% load, if the motor it will be gives 70% efficiency. Like that we are assuming the load and we are calculating the efficiency. आपण लोड काय करतोय, assume करतोय आणि त्याची efficiency calculate करतोय. So we are not putting direct load on the machine. मशीन वरती किंवा मोटर वरती directly load put करत नाहीये. We are assuming the load and understood the performance like efficiency, understood the performance, other performances like whether the commutation is suitable. So this performance it can be judged by conducting this test, and we are conducting or we are able to tell this is the indirect method of testing. आपण त्याच्यावरती डायरेक्ट लोड पुट न करता काय करतोय, इनडायरेक्टली त्याचं टेस्टिंग करतोय. म्हणजे मशीन वरती 50% लोड अज्युम केला किंवा लोड दिला तर त्याची इफिशियन्सी किती असेल, दॅट मीन्स वी आर डुइंग अ अजम्पशन and calculating the efficiency. That is, it is the indirect method of testing. ही जी काय आहे, it is nothing but it is the indirect method of testing. Okay, so it is the indirect method of testing. So this is nothing but a Swinburne test of DC shunt motor, or this test it can be carried out on the machine whose flux remains constant. ज्या machine चे flux constant असतील त्या machine वरती आपण ही टेस्ट काय करतोय, कंडक्ट करतो. Now advantages of this test is that there are some of the advantages of this test. The efficiency can be determined at any load because constant losses are known. We people are knowing the constant losses, or you are having the constant losses. आपल्याकडे constant losses आहेत. So we are able to tell the efficiency, or we are able to determine the efficiency at any desired load. कुठल्याही लोडला आपण काय करू शकतो, त्याची इफिशियन्सी कॅल्क्युलेट करू शकतो. ओके, वी आर एबल टू कॅल्क्युलेट द इफिशियन्सी ऍट एनी लोड बिकॉज वी नो द कॉन्स्टंट लॉसेस. नाउ वी आर ओनली रनिंग दिस मशीन ऑन नो लोड कंडिशन, किंवा वी आर कॅरिड आउट ओनली रनिंग टेस्ट. सो पॉवर रिक्वायर्ड फॉर दिस टेस्ट इज व्हेरी स्मॉल. बघा, पॉवर रिक्वायरमेंट जे आहे ही टेस्ट कंडक्ट करण्यासाठी इट इज ऑल्सो व्हेरी small. Now the power required to carry out this test is small because it is on no load test. Okay, so because we are performing only no load test, or we are performing only running test, due to that the power taken from the supply, it is very small, or it maybe it is just required to overcome the no load losses. So power requirement to carry out this test, it is less or small, and this method, it is quite economical and convenient. ही जी काय method आहे, so this method, it is economical and also it is convenient. This method, it is quite economical because power requirement for performing this test, it is less or it may be small, because so that it is economical. Also this method, it is convenient for small as well as big size of machine or large size of motor. Large size च्या motor साठी पण काय आहे, convenient आहे. Okay, so these are the advantages and disadvantages. Now advantages. Now disadvantages of this machine is that we are not able to tell, that means it does not take into account the stray load losses. याच्यामध्ये आपण stray load losses account मध्ये consider करत नाही. It does not take in the account of stray load losses. Stray load losses, it cannot be taken into account. So due to that, stray load losses is not taken into account. Due to that, the stray load losses that occur when the machine it is loaded, we are not able to tell when the machine it can be loaded whether there is a stray load losses are present or it may be not present, or how much quantity we are not able to take. Again, this test is not give accurate efficiency. This test, it is not gives accurate efficiency of the machine because we are not able to tell that the constant losses or the iron losses at a particular load, whether it will be same or the greater. Okay, that means because of the iron losses under actual load are greater than the measured efficiency. म्हणजे actual load ला iron losses हे काय असतील, greater असतील. So we are not able to calculate the accurate efficiency. And this losses is increased because of there is an armature reaction effect, or it may be armature reaction distortion. Okay, so armature reaction distorting the main flux. Due to that distortion, there is a change in the iron loss. So and this is not iron loss, it will be not taken change, it will not taken into account. So we are not able to calculate the accurate efficiency by performing this test. And the next one is nothing but the full load due to armature reaction flux is distorted. In some case which is increases the iron loss as much 50%. काही cases मध्ये हे iron loss 50% ला पण increase होतो. Another one disadvantage is that we are not able to tell whether the commutation process it is satisfactory. Commutation process it can be satisfactory for that particular load, because we are assuming the load, we are not directly putting the load on that machine, so we are not able to tell whether the commutation it is satisfactory or not. This is one disadvantages. Another one disadvantage is that we are directly assuming the load. Suppose we are assuming 80% load, we are assuming 90% load. At that situation, we are not able to tell whether the temperature rise of that of winding it is in the specified limit or not. म्हणजे जे काय लोड आपण अज्युम करतोय, अज्युम केलेल्या लोडला आपण मोटर पर्टिक्युलर त्या लोडला पुट न करता आपण जस्ट अज्युम करतोय. ड्यू टू दॅट अजम्पशन, whether that much amount of load it is actual put on the motor, जर तेवढा लोड ऍक्च्युअल मोटर वरती पुट केला तर त्याचं जे काही टेम्परेचर राईज होणार आहे, that means rise in temperature, whether it is in specified limit or not, it is also not able to tell. Okay, so these are the some of the disadvantages of this test, that is Swinburne test, and it will becomes under indirect method of testing. It will becomes under the indirect method of testing. Okay, getting लक्षात आलं? हॅलो, hello, all of you getting now?
Yes, sir. Yes, sir.
Okay, so in this way we will conclude this today's lecture, and we will stop here. In the next lecture we will see the next one point. Thank you.